You learned about the inverse of a matrix and you learned a direct formula for a 2 by 2 matrix if this matrix was invertible. A 2 by 2 matrix A given by A, B, C, D is invertible if the determinant of A times D minus B times C, is unequal to 0 and has inverse 1 over the determinant of A times D minus B minus C A. If the determinant of A is 0, A is singular or non-invertible. Today you will learn how to calculate the determinant for any square matrix. You can use determinants if you want to calculate areas, inverse matrices, and even determine whether a quadratic function has a minimum, a maximum, or a saddle point. To obtain the determinant for an n by n matrix A, you first need to learn some notation. Aij is a submatrix obtained from A, where we have removed row I and column j from A. For example, if A is the 4 by 4 matrix shown, A32 is given by the first, third and fourth column of A, where you skip the third component of each column. Now we can define the ij cofactor Cij of A as minus 1 to the power I plus j times the determinant of Aij. Note that you need a determinant to calculate a cofactor. As an example, the cofactor C23 of the 3 by 3 matrix is given by minus 1 to the power 5 times the determinant of 1, 5, 0, minus 2, which becomes 2. To remember when you need a plus or a minus 1 in a cofactor, you can remember the alternating pattern starting with a plus at the first entry. Now you are ready to find the determinant of an n by n matrix. The determinant of an n by n matrix A with n greater than or equal to 2 is given by the recursive formula the determinant of A equals A11 times C11 plus A12 times C12 and so on until A1n times C1n. The determinant of a single value is the value itself. We call this way of calculating the cofactor expansion across the first row of A. Now you can calculate a determinant. Let's do a 3 by 3 matrix first. First, you do the cofactor expansion over the first row. Then, you use the formula for the determinant of 2 by 2 matrices. Finally, you simplify and end with the value minus 2. In this example, you can see that the third cofactor is multiplied by 0. Now you can compute the determinant of a larger matrix. For instance, the shown 5 by 5 matrix. The cofactor expansion over the first row gives 5 terms, of which 4 will be 0, so we will skip those. You get 3 times the determinant of one 4 by 4 matrix, and then by doing another cofactor expansion, 6 times the determinant of one 3 by 3 matrix. This last determinant was minus 2, so the determinant becomes 6 times minus 2, which is minus 12. In the example, because of all the zeros in the first 2 rows, the 5 by 5 determinant was easily reduced to a 3 by 3 determinant. For a full 5 by 5 matrix, how many 3 by 3 matrices would there be? Turns out there will be in total 20. In class, you will learn how to handle large and full matrices. See you soon!